So the speed of a small jet aircraft was measured every 5 seconds, starting from the time it turned on the runway until it left the ground. The results are given. Using all this information, estimate the length of the runway used by the jet to take off. So what I thought was a good idea for this question is just to get a little sketch of the graph. We've got a speed time graph. I use V for speed and T for time. It doesn't have to be perfect. Okay, this is just one I prepared earlier. So I've got 0, 2, 5, 5, 10, 10, 15, 18, maybe about here, 20, 28, and 25, 42. Okay, so we can see it's going up. Looks a little bit like a quadratic. We don't know that it's a quadratic, of course. Okay, and using that, we want to find an estimate for the length of the runway. So actually, that's going to be the distance traveled in that time. And this is given by the area under the graph. Of course, we've only got points here. We don't actually have a curve. But to estimate it, what we can use therefore is the trapezium rule. It's actually not the only thing that is accepted in the answers. I'm going to recommend having a look at the answers if you want to see more ways. There's 7 accepted, but I'm going to talk through the way that I did it, and I think it's probably the most logical one. So what we can do is, well, I'm going to kind of just join the points up. Actually, this comes in later on, but what we do is estimate using trapezia. So I just draw lines going up. And instead of the smooth curve, we've got these straight lines like this. So I've got 1, 2, 3, 4, 5 trapezia. And therefore, I'm going to write down, I am doing an integral under a function. I just don't know what the function is. I'm doing it between 0 and 25, but let's focus on the right-hand side. It'll be a half times 5. 5 is the height of each trapezia. And then for me, it'll be y0 plus y5 as my as the ones that go by themselves, because that's these two here, and then it's 2 lots of the other ones because all the rest are kind of linked to 2 trapezia. So 2 times y1 plus y2 plus y3 plus y4. So that's actually it's 2.5, and then I'm using the speeds from now on. 2 plus 42, the smallest and the largest, and 2 times 5 plus 10 plus 18 plus 28. So it's quite subtle, and often questions sort of just say use the trapezium rule. You've got to realize to do it here. Okay, 2.5 multiplied by 2 plus 42 plus 2 times the rest. 10 plus 18 plus 28. I just realized I forgot the 5. Okay, close bracket there, close bracket again, gives us an answer of 415. That is our estimate for the length of the runway. But then, given that the jet's actually accelerated smoothly, that's the red curve that I drew originally, essentially, explain whether our answer is an underestimate or an overestimate for the length of the runway. So this is saying, like, is the actual area under the curve. I just realized, for some reason, I didn't join the first one up. Is the actual area under the curve more or less than the area given by the trapezia? And that's why a sketch goes a long way. You can see it's only very slightly, but the small gaps and the trapezia are going to have a larger area than the actual area under the curve. So as long as you say something along those lines, then you're absolutely fine. I'm just going to show you the answers. So yeah, the top of the trapezia lie above the curve. That's one way of saying it, or the area is greater. I think that's probably the simplest thing to remember. I actually went with the curve being convex. So when a curve is increasing, going up like that, it's convex, whereas concave is when it goes down like that. It looks a bit more like a cave because the gradient is decreasing. So it's worth kind of being aware of that because that's when you get the trapezium rule actually overestimating. It's a bit harder to remember though than the first two, so maybe stick with that. A good diagram can work. Second derivative is greater than zero. That's the same thing as saying it's convex. Acceleration is continuing increasing, gradient's increasing. That was also accepted. Or all the rectangles are above the curve. That would be if you, instead of using trapezia, you actually used rectangles to approximate it. It won't be as good. Actually, it depends if you use a left-hand sum, to be fair. If you use a right-hand sum, you get an underestimate. But I'm not going to talk any more about that. I would say trapezium rule is the way to go here. So let's focus on those explanations for why it's an overestimate.